So the last part in this section, we're going to do angle proofs reference, and then we'll go through the practice, and then you'll pretty much be on your own with the proofs. And we'll just see with the time and how it goes. But first, we're going to start here. You definitely want to start here. If you're going to understand how to do angle proofs or proofs in general, this is helpful to start here. All right. So we have a word bank at the top. Those are the words you need to know. So for the definition of congruence, I just want to go back through. We already should be familiar with the definition of congruence. The thing that changes is this symbol changes. The symbol changes. Now, an angle bisector. So I want to show you two congruent angles first. So if I have angle A and I have angle B, the way that I show that they're congruent, is I use an arc. I use this little arc mark. I come over, put a little arc mark here. These two angles are congruent. That means they're congruent. That's a visual of congruence. You need to do the same thing. Now, when a bisector divides an angle into two equal parts, well, draw your angle. Here's my bisector. I'm going to call it BI. And it divides angle MIX into two different parts. But they're also congruent. So IB is a bisector. IB, write it down, is a bisector. It divides it into two equal parts. And remember, the way you show that something is congruent, you use the arc marks. This angle, MIB, equals this angle, BIX. Okay? We showed that these are two congruent angles. Now, for the third one, definition of complementary angles. Complementary angles have a sum that is 90 degrees. So if I have a right angle and it's split into parts, I can kind of conclude that the sum of these two angles, call this angle 1 and angle 2. I can conclude that angle 1 plus angle 2 equals 90 degrees. Okay? I can also say the converse. 90 degrees equals angle 1 plus angle 2. That's what I can assume. You need to write this down because you're not going to see the definitions. You're going to see it in the way that I'm writing it. So you need to write that down. Now, the definition of supplementary angles. It's just saying you have two angles. Let's say we have separate angles. This angle is 20 degrees. And then I have another angle, the blue angle, you don't see. Doesn't look like that. Looks like this. Here's my other angle. And this angle, it's 160 degrees. This angle is 160 degrees. Well, a 160 degree angle, my blue angle, plus my 20 degree angle, equals 180. Let's call this angle B, and we're going to call this angle A. So basically, angle A plus angle B equals 180 degrees. They are supplementary. You put them together, you can make a straight line. Now, the symbol for perpendicular is this symbol. It's a T. It's an upside down T. I want you to go back up to your word bank. Put symbols. Perpendicular and the word parallel. This is perpendicular, this is parallel, or parallel. Okay? The railroad track. Now, perpendicular lines form right angles. So if I have two lines that are perpendicular, then I know, first of all, that this angle is equal to that angle. And they form 90-degree angles. A lot of different things there going on. Last thing, if I see a picture of a right angle, I can say by definition, angle 1, if I call this angle 1, is a right angle. I automatically know. It's kind of like, it's an axiom. It's something that we kind of automatically know. The angle addition postulate, so you can see a little bit more clearer. That's just saying angle ABD, that's this angle. Angle ABD equals, no, plus angle BDC, plus that. You add them up, and they equal ABC. Add these two angles together, and you get the whole thing. So a part plus a part equals a whole. You can think of it that way. A part plus a part equals a whole angle. Part of an angle plus another part of an angle equals the whole angle. Now, the vertical angles theorem, I'm going to draw a picture of those angles. Vertical angles looks like this. These are my vertical angles. Carl said this is angle 1, this is angle 2. These angles are congruent. They're congruent. Remember how I said to do congruence. So I'm just going to go back through and do it in red. Angle 1 is congruent to angle 2. So we might say angle 1 is congruent to angle 2. Okay? And no matter how you turn that, how it looks like, any angles that are opposite to each other are congruent angles. These are vertical angles. Now the complement theorem, let's say we have an angle, it's a right angle. And remember before, I said have angle 1 and angle 2, we can write a statement. Angle 1 plus angle 2 equals 90 degrees. For the supplement theorem, we have a straight line. I can assume, and we can say, we'll say that this is 50. Now I know that this other angle over here, 180 minus 50 is 130. I know if I add these two angles together, this is angle 1, this is angle 2. If I add them together, I can say they equal 180. So angle 1 plus angle 2 equals 180. And you can prove it. What's 130 plus 50? Does it equal 180? Yeah, it does. All supplementary angles do that. If you add them together, they equal 180. Congruent complements theorem, that's basically saying if you have two right angles, let's say I have a right angle over here. This is 90 degrees. Let's say I have a right angle down here. I can conclude that these two things equal each other. These two angles equal each other. I'm going to highlight the angles one time. This angle down here, this angle equals this right angle. Because they're both 90 degrees. There's no way you can get around it. Congruent supplements theorem, 180 degree angle equals another 180 degree angle. It's bananas to like confuse it beyond that. So I'm gonna leave the angle reference section to that. and create a different part for you if you need to check your answers. Okay?